Filing disclosure. Okay, so we made a promise that we would file disclosure in a sense that 1000 to 2000 disclosure in next 6 months or 1 year. So we have started, and probably in few hours or by today you can see the disclosure. So we will file at medium.com first, and then slowly we'll propagate to other places if they accept it. So this is the disclosure that is in first time in artificial intelligence and machine learning. So this is demonstration about the clustering algorithm that takes place in unsupervised way of learning in machine learning. So unsupervised way of learning where you don't have labeled database. The database is not labeled, so that you can create a mathematical formula or model that will be based upon the label database, and that can be used that formula to do the labeling of the new coming the data based upon that mathematics. That is not possible in a way. The database is not labeled. This is most natural database. Then rather than not doing the direct mathematics, generally we cluster the database into different sets, and typically we give the classification of each cluster as one class. So clustering happens through many ways. One of the way is hierarchical. Okay, so that is one way, top to bottom approach, bottom to top approach, agglomerative and divisive. This is also called bottom to top is agglomerative, and top to top to bottom, I believe, that is agglomerative, and bottom to top is this divisive. So this is some way. So agglomerative and divisive. So hierarchical way is one way to do the clustering, DB scan, the density base. That is another way. Then k-mean. K-mean, number of k cluster we fix at the beginning, and then we distribute all the sample data, and we do the mathematics that we find that which sample data belongs to which cluster. If I say I think there are three clusters because I want three different clusters. There are three clusters. They're all data in the data set, or we call it document vector also. All the document belong to which one of them? All are exclusive. Okay, this is also called hard partitioning. Soft partitioning is each document partially belongs to every cluster. What percentage that we have to see. In hard partitioning, one document must belong to only one cluster. So in k-mean, k is number of mean centroid. So k centroids, if I set at the beginning only, then what is the distribution, which document belongs to which centroid, that we have to decide. This way we can create k number of clusters, and then since I have k number of clusters, that much grouping I have already done it. So in unsupervised learning, clustering way, in unsupervised learning, there except other than clustering, that is DB scan or hierarchical or k-mean, there can be other way in the cluster in the unsupervised learning like dimensionality, reduction, and other way also. But in clustering, the k number of means that we will see. Then anyway, it is available, and there are tons of books that talks about k-mean algorithm. Then why there is new way to talk about the k-mean algorithm? It is available. Okay, new in the sense that our description for any problem is different. That is seen in through our technical video. The way we describe the technology is proven it is different than whatever the other authors they describe it. Plus, we are giving 5 real life example that is typically missing in any of the book or tutorial. Okay, generally they describe the algorithm what is available in the sklearn on scpy Python library that they will use, and they will. We are using the ready-made library also. We are developing from the scratch. From the scratch came in algorithm. The initial centroid detection that also came in plus plus algorithm that is called, that also we have developed from the scratch. So everything from the bookish way and from the scratch, both we have developed. from our own. Both things we are showing what is available as a library in the market and what is how we can develop those things. And then we have tested against 5 examples to different distance metrics. Generally, people use Euclidean distance, but we are using cosine distance, and these are not available this much of example anywhere else. So it's like developing the K-mean algorithm from the scratch itself. Okay, so this disclosure today, but today it would be available at Medium. So Medium, Medium, medium.com / at the rate meaning MINHINC or MINHINC meaning dot medium dot com. Okay, so meaning dot medium dot com or medium.com / and then at the rate meaning MINHINC. This is the channel name MINHINC without a space. Medium.com / at the rate of MINHINC. There it will be available. One disclosure is already available and that is included by some Python grouping. So Python grouping group is a well-known group and they have included this kind of this meaning kind of meaning ID along their kind of set of region they are handling the Python research work. So we are there now. This is message I have received, and it is followed by one person. So it would come in meaning.medium.com or medium.com / at the rate of meaning. So this disclosure would be visible by today. That is the concept. So this is the commencement of the promise that we have done for the what is extra here that we are proving the various distances, Euclidean distances or cosine distances. Whatever the formula we are using, that is also called the objective function of the K-mean. That why we are doing, how we are writing the algorithm of the K-mean. If I am writing algorithm for the K-mean, then it should be proved mathematically. It comes to calculus because if I have document vector, then it comes to calculus. We have proved this through both ways. Euclidean distance we are using to do the reassignment phase and cosine distance we are doing for the reassignment phase. Both phases, the calculus, the multivariable calculus that is used both way through the calculus, we have proved the K-mean algorithm. This is amazing and this is not anywhere else available. So we are new. So we are not new, only the writing from the scratch, different from the others, and 5 examples we are giving. An example is in Euclidean distance and cosine distance. The calculus what we have used for the cosine distance, for Euclidean distance it is available. For the calculus what we have used to prove our approach through the cosine distance, it is only available to us. It is in disclosure. We are placing it and we'll see if it is patentable. So that we will see. So click on the meaning.medium.com or medium.com / at the rate of meaning. Okay, by today, and this disclosure would be available. That is the concept. It is in series of hundreds, thousands of the disclosure that we have proved that it would come.